Good evening, class. Today we're going to look at implementing an existing physics engine within one of our games. So in this case, we're going to be using the Aether2D physics engine, which is a two-dimensional physics engine that's built for C#, and it actually has a one of its possible builds is specific to X and A, so it uses all the X and A vectors and matrices and all of the mathematical tools that come with X and A. So let's go ahead and take a look at that. We've got, like we often have, a starter project. So this one's very similar to the last physics example, where we're basically creating a number of balls that we're going to have bouncing around the scene. And couple, I don't remember if I've shown you this before, but I've actually declared a constant static class that just has a game width and height, making it easy to get those values out. So anywhere we need to use those, we're going to say constant.game width and game height, and we're pulling that out for the preferred back buffer width and height. And I just realized that I forgot to invoke apply changes to actually make sure that our window is that size. Now that's the default size that the game starts at anyway, so it really doesn't matter if we don't have that, but if you change those values, that's what needs to be there to make that happen. So in the initialize, we're creating just a ball sprite. We're initializing a random number generator to generate a random radius. So this is very similar to the past example, only we're not setting the position now. We're going to do that with the physics engine. So the physics engine will manage that for us. And then we're loading the content for the balls, we're updating the balls, and we're drawing the balls. So very much the same thing we did last time. If we look at the ball sprite class, we have a texture, we have a radius, a scale, and an origin. We have a boolean to determine if we're colliding that's set internally in this class. We have a constructor that takes that radius and figures out how big everything should be. We have the load content, which loads the texture. We have our update, which is just setting that colliding to false at the start of every frame. And then we have our draw, and we're using that colliding to determine a color that we're going to draw with, but we're not actually drawing anything yet because, again, that's going to depend on our physics engine. So let's go ahead and look at how we get that physics engine into our game. So this is actually a available as a NuGet package, so we can either right click on dependencies and go to manage NuGet packages, or we can go to tools and come down to NuGet package manager and go there, and we can do it through the console or we can do it through the NuGet browser. So we want to make sure we're on browse. What we're looking for is Aether2D or Aether Physics 2D. And notice the first package is Aether Physics 2D. Now this is not the one we want to use. We want to use the one specific to MonoGame. So Aether Physics 2D.mg is the MonoGame one. So we're going to go ahead and add that to our physics example D game. Click the install button and agree to the terms. That's going to download that NuGet package. And we might also want to get the Aether Physics 2D Diagnostics package as well, and that just allows us to turn on some diagnostics and actually get more information about what that physics engine is doing in the debug process, so that can be helpful as well. So we'll download both of those, and those run in the background, and once we get that installed, then we can come back to our physics game, and let's start with the physics game. So the first thing we need to do is, of course, add our namespaces. And once those have been installed, we should have a Tanacom namespace, which is where the Aether engine is, and Aether Physics 2D. And there's a lot of different packages in here for doing fluids, for doing dynamics, for dealing with collisions and things like that. We are going to be using the dynamics portion of this, the dynamics library. Now, one of the things that comes out of that library is a world class. And the world class represents the physical world that we're simulating. So we want to go ahead and construct that, and we can do that right here in the initialize. So we'll say world equals new world. Oh, I need to give that a name. Let's actually call it world lowercase. Okay, so lowercase world equals a new world. So we're going to construct that world object, which is going to basically maintain all of the physics objects in the world for us, as well as applying the effects. And we're going to add a gravity to that as well. So gravity is just a property of the world. It's the direction gravity is pulling. In our case, we're going to set it to the 0 vector. So effectively, we have no gravity. Again, this is kind of a riff off the last balls bouncing around the screen one. So we're kind of looking top down at maybe a billiards table or something like that. So we don't need any gravity. Now the other thing it introduces is the rigid bodies, which are bodies, and we want to create a rigid body for each one of these balls that we're creating. And I'm going to go ahead and do that here in the initialize method, just because we've already got this loop and we've got a random number generator. We could also have done it in the ball sprite, but so our body is going to be a new, or actually we create these from that world object. So we actually have to say create body, but the kind of body we want is a circle. So we're going to create a circular physics body. We're going to supply a radius, which we're going to use our radius that we just generated. And we need to supply a density, which helps us figure out how heavy this is going to be. And let me see what values I was using in my example that I was working on. Never mind, I did not write them down. So I'm just going to use a density of 1. Then we need potentially a position. I'm actually going to calculate that. Var position equals new vector 2. And I want this position to be the x to be between 0 and the width of the screen. So we'll do lowercase random. Next, and I'll just use the integer version because one of its overrides, the second one actually takes just a max value, so it gives you a number between 0 and that max value. And we'll use constants.screen our game width _width. And then we'll go ahead and actually, I don't want to use that one, I want to use the one that actually, because we want to make sure these stay on screen. So we'll set the radius as the smaller number and game width minus radius as the larger number. So that's our x value. And then our y value will do the same thing. Random.next radius, and then game constants game height, subtract the radius. This just ensures that they are all going to be on screen. And we got to close that. There we go. And then we can go ahead and pass that position in. And then the next argument is the body type, which you can see it has a default value of static, but we actually want this to be a dynamic body. Dynamic means that it's going to interact with this dynamic system. Things are going to bounce around and behave the way that we want them to. The other one, kinematics, has to do with joints and simulating joints, which the Aether physics does as well. So there's a lot of interesting stuff that we can do with this engine. This is kind of the most basic use that we're setting up here. So we've created our body, and one more thing we want to do, we want to create a restitution, which we do a set restitution, which gives us a value that is going to be between 0 and 1 for how elastic this collision is. And if I remember correctly, because I did not write it in my notes, 1 is a perfectly elastic collision. So we'll try this, we'll see if this works. Otherwise we might have to switch it to 0 or somewhere in between. So the other thing I'm going to do is I'm going to pass this new body into the ball sprite constructor. So in our ball sprite, we're going to update our constructor to take a body which is in that Tanacom namespace. So we need to make sure that we have access to a body. And then we'll also save that in our private variables. or not vector2, that should be a body. So in here we can say this dot body equals the body that was passed in. And these ones really won't need to change, but we are going to draw our ball based on this information. So we'll do a sprite batch dot draw, and we'll take in our texture. And for the position, we're actually going to use the body's position. So and then we can use this color that we have defined here. Alright, so if we save that, and actually if we run the game now, we should actually see our balls positioned randomly in the world. And there we have them. Now they're not interacting yet because we haven't actually turned on or started using this physics engine. So the next thing we have to do is in our update, we want to update the physics of the world, and I'm going to do this after we update the balls. Remember, our balls actually set that colliding flag to false, so I'm going to make sure that those start as false before we update our world. So in here we just do world.step is the method, and we're going to tell it how large of a step we're going to take, and that step is just going to be how much time has elapsed from between this frame and the previous frame, which we can get from that elapsed game time total seconds. And this needs to be cast to be a float. So that should advance our simulation if we run this again. You see our balls don't move because we did not give them a velocity. So let's go ahead and add a velocity as well. So basically the same way we did the position, we can create a random velocity, and this is going to be a linear velocity, so we'll go ahead and add that there. A new vector2 and random.next. And let's give it a velocity between -1 and 1. Actually, let's make this a vector2, and then we'll assign it. So I can actually... No, let's leave it as it was. Sorry. But let's make this -10 to +10. So some of these are going to be sitting still, and some of them might be moving a little bit. See what that looks like. We may want to change this a little bit. Use some different values. So there they are. They're moving quite slowly, but you can see them moving. And you can notice that once they move off screen, they are no longer visible to us. So let's go ahead and step this up, make this a little faster. But then we're also going to add some borders, and those borders are going to keep our balls from moving off the screen. So to do that, we are going to come into here and world.create edge. And each edge is basically a line, so a vector from a start to an end. And we're going to go from 0 to constants dot vectors. So to help with this process, let's go ahead and create a couple of vectors. So we'll have var actually set top to 0, var bottom is going to be constants dot game height, and var left will set to 0, and var right will set to constants game width. And then we're going to create vectors that are going to give us some edges based on this. So we'll create edge, new vector2 from top left to new vector2 top right. And then top right to bottom right. And then we'll do bottom right, or bottom left to bottom right. Really doesn't matter what direction these are declared. And then top left and bottom left. Okay, and we actually have to set some values on these, so I'm actually going to create edges equals new body array, which is going to contain all of these. And as initializer, these need to be commas. We're using initializer syntax. And there, now we have an array of bodies, and we can iterate over that array. And now let's call it edge rather than body. So each edge is going to be a static body type, so they don't move. Once we've kind of put them in position, they're going to stay there. And actually, we don't have to set that because that's actually the default, but we'll go ahead and do it anyway. And edge dot apply, or sorry, set restitution, and we'll set this to, what do we do on the balls? 1, so we'll see if 1 is the right direction or if it should be 0. And I think that's all I need to do with those edges. That should give us something to bounce off when we get to the edge of the world. And it looks like I have some bouncing. They're bouncing off each other. Oh yeah. Circle, radius, density, position, dynamic. I am missing something here. Let me take a quick look at my notes. So, which unfortunately I did not write that part down. Ugh. Let me pause. Well, apparently there's no pause. So I didn't write it down, but I do have it on another branch. So let me stash these changes. Check out my other branch. And world gravity, world create edge. So I created 4 edges. That's pretty straightforward with 4 edges. Body type to static, restitution to 1. And did I do anything else with these balls? That should be it. Not seeing anything different from what I just did in this example. So I'm not quite sure why it's not behaving. But let's go back to our example. And Pop our changes. Okay, so we have a world, we set our gravity vector, we are creating top would be 0, left would be 0, bottom would be height, right would be the width. 0 to 0, right? Yep. Then we have up left to top right. No, top left to top right. On this one I had bottom left. So that's the left side. This one top left to oh! Yeah, I got these backwards. This should be left and top, because left is the X. That's why we were having some weirdness, is I think I've got these pointing in the wrong direction. So left and top, and then we'll do right and top. So that's our top line. And then top and our left and top, and left and bottom. That's our left side. And left and bottom to right and bottom. That's our right side. And then that's our bottom. And then left and top to, right and top to right and bottom. So it will be our right side. So I had the rectangle oriented the wrong way, so all our things, some of them were outside of the rectangle and some of them were within. This should hopefully make them behave a little bit better. So there we saw that ball bounce off the edge. We're seeing the balls bounce off the edge here. Interesting that they're getting that far off screen. And yep, that's because they have that radius. Oh, that shouldn't matter. That should not matter. Okay, so then for each edge, we make the body type static. We set the restitution to 1. And this, of course, is a floating point number, so we could specify that. It should work that way. And we have our balls. Radius is going to be between 5 and 50. And then our position is going to be random number between X and Y, so that should be fine. And we want the body type to be dynamic. So create that radius. I was using 1F value for density, so that should be fine. And linear velocity between -50 and +50, that should work. That all looks fine. Not sure why some of our balls are not behaving. Let's crank this down in numbers. Just put 5 in. It's almost like the radius we're drawing them with is not the radius that they actually are. Which may be the case. Let's look at our ball. That's right. So So we're setting our scale to be radius minus 49 because we think our ball's image, which is a circle sprite, is 49 pixels by 49 pixels. Let's double check. And I have to take a look at this in File Explorer. Go to its properties, go to its details, and this is 98 by 98 pixels. So half of that would be 49. Is that what I'm dividing that by? So that should give us a scaling that's what it is. We're not actually scaling our drawing, so they are not actually matching up with their size. So let's go ahead and apply that scale so they're actually the right size. So we're going to go ahead and use one of the variants on this. So we need a null there in order to apply a scale. We need a rotation, which actually the body has a rotation value that we can use. The origin is this origin that we calculated there. And then sprite effects none. Put the layer depth at 0, and I didn't use the right override because I'm missing the scale factor. So we need one that takes a vector, a source rectangle, rotation, origin, and then a scale value, which is going to be our scale. And now if we draw it, our balls should look right. There we go. Now they're behaving the way we expect. So the problem was all our balls were being drawn the incorrect size. So now they're behaving much better, and let's go ahead and put back in some more balls. So we'll make this back into 20 so that we have a few more bouncing around the world. So there we have, and notice that now because we added that angle, when these hit off center, they actually apply some torque to each other, so they will actually start spinning. And we could even amp that up a little bit by making them start with some angular velocity to begin with. So angular velocity, and set that equal to some floating point value, random. We'll use next double, multiplied by math helper dot pi. So, and maybe subtract math helper dot pi over 2 so that some of these will be rotating in a negative direction. And we have to cast this random to be a float value. That should all be floating point multiplication then. That should make it happy. And now we'll have balls starting off spinning, and notice that they apply those values to each other. And we have basically everything we want out of this, except for one thing. We're not changing the color of these when they actually collide. It would be nice to be able to know when they collide and be able to use that information, but all of that is actually stored within this world, and how it actually gets exposed is through an event handler. So we need to actually write an event listener to capture that event, and we'll write a collision handler rule, and this is going to be private, so we don't need to provide a public. And the structure of collision handlers for the Aether2D engine is a bit different than what you're probably used to. So there's a fixture is the first argument, fixture, other, and contact. And these are all actually defined, or some of them are defined in the Aether Physics2D dynamics dot contacts namespace. So we have fixture, other. So the fixtures, this is the one that detected the collision. This is the other thing it's colliding with. So these are effectively our two bodies. And then the contact describes the details about that collision. And we want to go ahead and basically change that colliding property to true. So this is really kind of a very simple example. We might also add a sound effect and have that sound effect play. And this also needs to return a value, and we'll just return true to say that, yeah, we want the collision to be handled normally by the engine. If we return false, then I believe it would assume that we're dealing with the collision ourselves, and we'll take care of it. And we'll check that, because that's actually a good thing to know. But up here in our constructor, we're going to go ahead and apply that event handler. So this.body on collision, we'll add our new event handler. Which I can't remember what I called it. Collision handler. Okay, so now if we run this, we should see these balls flash momentarily when they make a contact. And of course that's only happening for one frame, which is why it's so kind of just blinky for a very fraction of a moment. But that's enough to verify that we're actually detecting that collision the way we expect. Now let's try setting this to false, because I think what that means is that we are saying we're going to handle the collision ourselves and deal with the outcomes. And there you go. You can see they now pass through each other. They pass through everything. We're saying we're taking care of that. We could also try to filter for when the colliding object is a ball, or when it's colliding with a wall, and deal with it that way. But that really wraps us up. That's enough to kind of get the basics of physics up and running. If you want to learn more about what you can do with this physics engine, I do have the samples, the Aether2D samples, which I've converted to run with MonoGame. That is not it. Where did that editor go? Oh, it's actually up. So this is the Aether2D samples. Right now I've got it set to the samples project. We can go ahead and run that, and that gives us the list of all their samples, and we can pick any of these that we're interested in, like stacked objects. Shows how we can create lots of rigid bodies and interact with them. There's a lot of interesting things we can do. Actually, I shouldn't have done that. I should have just escaped. So I would suggest you go in and take a look at some of these. Breakable bodies, pretty interesting. We can create an explosion. We can snap and break things. There is also even a little bit of a game that you can play with and see kind of how we can use physics to model acceleration with actually physically modeling how a car might move in our world. So some interesting things in those samples. We also have, there's actually 4 projects in here. So the original samples, this is actually from way back when, the Farseer engine, which is what Aether is based on originally. They've added some new samples that are focus on some of the new features of the Aether engine. So I'm going to set this as a startup, take a quick look at those. And it has a lot of the same ideas, the stacked bodies. This looks very familiar. But then we also have things like soft bodies and path generation, advanced dynamics. So this web, things are actually pulling one apart from each other. So it's really cool stuff in there. One of the interesting things they do have is there is an Svg Importer that they've added to the content pipeline, which will actually import SVGs and then turn them into rigid bodies. So these are actually what was the instructions on this? Oh, just loading the vertices from an SVG. So not actually doing anything with it. Here's where they convert it into bodies. And so these are actually rigid bodies that can be interacted with. So there are some real interesting things that they've done there. Those importers are in this Svg2D importers library. Getting them working is a little bit interesting, but you could actually build this Svg2D importers DLL, and as long as you end up putting it in the content folder where you're building your content, and you can just pull this one actually, then the sample or the MGCB builder will actually pick that up. So notice that if we get into here, we have a couple SVGs, and notice that it is pulling in the Svg2D SVG importer and processor to actually build that SVG. So it's doing that and it's building it. It's using what's declared with that to pull in those SVGs and turn them into basically some kind of SVG based texture and vector class that kind of combines those. And let's see, I think that's not in the content project. Svg2D, yeah. So basically, it's building a polygon container plus texture, and you can get in and look at the samples and see how they've actually set all that up. Haven't dug too deep into it, but I did have one of the students asked about loading SVG files. So it is possible, and if you have an SVG file, you can potentially turn it into a physics body using this engine, which is an interesting kind of advanced use. So that's where we're going to wrap it up for today. So hopefully you find this useful, especially if you're planning on building a very physics-oriented game, and we'll see you later.